Action!
Hi, everyone. I'm Beth Johnson, and with me, as always, is scientist Franck Marchis, and this is the Grudge Report, SETI Institute's science show following Star Trek Discovery's latest episodes. Some of you have been watching the Expanse ones. We cover that as well now. Spoilers abound, so if you haven't watched the most recent episodes, turn back while you still can. Hey, Franck, how's it going?
Hi, how are you, Beth? Long time.
I am, yeah, long time. It was a lovely vacation. I needed the time off. So I'm happy to be back, but I'm glad I got some of the rest I needed.
So we're happy to have you back.
Or how about you? Did you take any time off over the break or?
No, I just did some Grudge report for the entire winter
I
break.
know you so many Expanse episodes. So much fun.
So we're back with with Discovery. We did not forget you.
We did not forget our Discovery fans, all like 5 of you. All right, so what have we got today? So we are going to talk about the episode Sue Call. And I'll give you the quick rundown. This is where they finally go into the Virubin Nebula and try and find what's going on the surface of, inside the ship that's there on the surface of a planet that is made almost entirely of dilithium, which is why they went and hunted it down, apparently. So we'll get into that. And they find there a Kelpian by the name of Sukal. But things are very interesting as the entire ship is basically in a holographic program trying to educate this kid who's been alive for 100 and some odd years. And he is childlike and really has no idea what's going on outside of the world. And then they have to cope with all of that. So let's get going. So let's talk about the nebula itself. We've been talking about the Virubin Nebula a lot this season, so I know that was something on your mind again this time. So why don't you talk to us about it? What's up with this nebula, and what's really cool about it?
Yes, so you remember we mentioned the nebula, and last time we showed a simulation of it. It was yellow, and I
Yes.
apologize because I jump onto these details, saying I understand how a nebula can be yellow. And you mentioned to me, and you were right, that this was probably a simulation and they were just showing the filament of the nebula, the concentration of material, but it was not the real color of the nebula.
Right.
But we saw the nebula close and they will even go inside. They attempt to go inside with the main the Discovery spaceship. And it does look like a nebula that I had in my mind, made of dust and gas, mostly red,
Right.
and with a lot of ionizing radiation and a lot of lightning and a lot of motion and concentration of material, storms.
Right. And they were talking about how the hydrogen and helium and dust particles were collapsing in places.
Exactly.
So star
So it's
formation
some
is
good
happening.
science here.
Yeah, there was.
So let me talk about so first the nebula in the real world in the 2021. Sorry,
Oh, yeah.
nebula.
Yay!
Yeah. A nebula is basically a concentration, an area in space where there is a large number of concentration of gas and dust, and formation, star in formation most of the time. So
Right.
if you look at a nebula from the ground, you will see the Orion Nebula, the most famous one that we see in the winter at the moment. It's basically an area which is illuminated by a lot of very young stars inside the trapezium, and around it, what you see, it's red because we see the gas being excited by this light coming from the stars, and the red comes from the hydrogen transition. So in the movie itself, so we see there inside the nebula, they talk a lot about ionizing radiation. Let me talk
Right.
about
So the ionizing radiation seems to be causing a lot of harm here. They're having issue with the ship getting it into the nebula itself, and they actually have to switch to Booker's ship to get in there. and deposit people down on the planet, because Booker's ship, and I thought this was kind of cool, Booker's ship morphs.
Yeah.
So it actually like breaks apart and comes back together in different constructions to fit through some of these filaments that you're talking about, and avoiding these lightning flashes and things. And in the meantime, Discovery has to do a black alert and get back out. And the ionizing radiation is causing problems for everybody. Book,
For everybody, yeah.
Grudge. I'm still upset. Poor Grudge. My Grudge took some damage. And of course, you know, they're on limited time down on the surface before they go. The damage is too much for their medical technology to reverse. So what is going on in ionizing radiation that is causing all of this chaos and damage to the people and the ships?
So radiation, first of all, in science, encompass any a particle which is traveling at high speed or an electronic wave. So radiation can be either a particle like a muon, an electron, or something like a subatomic particles, or it could be simply light at a very high frequency, in a high energy in this case. So the characterization of ionizing radiation is that the amount of energy is strong enough to excite the atom, to transform the atom into an ion. So basically to
remove electrons.
Remove an electron. Yes.
Right.
Typical ionizing radiation that we know are X-ray that we use when you go to an hospital, but also gamma ray that we see in space. Those are very energetic emission radiation.
I always teach my students that, you know, when they're trying to remember the electromagnetic spectrum, that, you know, you can listen to the radio and there's no problems with it. Radio waves are long, they don't do any damage. But think about like microwaves and X-rays and gamma rays. You know, we're protected from our microwaves by the cages that are built in them. We're given shields when we're given X-rays, and gamma rays created the Hulk. So that's the damaging side of the radiation.
Yeah. And some high energy UV, the most energetic part of the UV, are also considered as ionizing radiation. So we quantify the energy of a photon in electrovolt. And if you want to look very bright and smart at dinner party tonight, you can just mention that ionizing radiation have a photon energy which is higher than 10 electrovolt, typically, or 33 electrovolts, roughly 10 to 33. It's a number. You can drop that in the middle of the conversation. For the particle part, here we are talking about particles which are emitted by radioactivity. So it's basically, in this case, it's an atom which is in an unstable state. So come back to the stable state, losing neutron. And in this case, we have emission of particles. That could be alpha particles, beta particles. There's plenty of type of particle or neutron particles.
Right.
And those can knock out as well the atom, exciting the atom or kicking out completely the electron. So we're going to go back to why those ionizing radiation are kind of dangerous for us, for human.
Right.
For that, I want to go back to the nebula itself. Something I completely forgot to mention, and I think it's important, is the lightning.
Oh, right. We wanted to talk about the lightning and what it can do.
So, you know, when I saw the show, I said, there is no lightning in Nebula, and I learned something. Like Googling,
you learned that there is lightning in Nebula, didn't you?
Yeah. So I learned something more complex than that. So I want to say what I learned recently, in fact. You heard about the chondrule, right? Those kind of tiny particles.
The chondrules are sort of small particles inside meteorites that we find.
They are basically, we know that they form by, they are solidified droplet of silica that melt very quickly and very quickly cool down. We know
which you get when you're coming through like the atmosphere of Earth and burning up very rapidly. So that quick heating, quick cooling can cause these.
But those we know that need to be formed some by another scenario. We know that did not form through crossing the atmosphere. They formed somewhere else, and we don't know how. And in fact, lightning in protostellar nebula has been kind of theorized to be the explanation. And there is groups of people who have been trying to develop modeling of nebula to show that lightning can form those chondrules.
Oh, now that's really interesting. Look at us learning some new science today.
And in fact, they did not succeed to do it yet. There is always some issue, apparently. I didn't read the paper completely yet, but one of the reasons is because there is not a higher density of material to conduct the lightning, because lightning work only if you are in an environment with an atmosphere or some kind of material to conduct the electricity, of course.
Right, you have to have a conductor, and hydrogen and helium not so good at that.
Exactly. So that's the reason the models are not working. But they are working on that. It's kind of something they think it exists, but they have not yet proven the existence of lightning in nebula. And I think, and then I want to talk about when this is a great moment, when they say there is an area of dust and gas collapsing, and you see the spaceship coming closer to being attracted by this somehow.
Right. Right. And I was like, oh, gas and dust collapsing. So we're talking a star forming right now. So that's pretty interesting that they just kind of threw that in there. Like, oh no, there's this thing happening.
So we call that gravitational instabilities, the technical word. And it's basically, you imagine that if you are in a disk of formation, a disk of planetesimals of gas and dust, okay? And you reach some kind of speed, specific speed, suddenly there is kind of this formation of nucleus, condensation of material. And they form very quickly, in fact. I don't know if they form in this order in time scale of a few seconds, like shown in the show. I thought it was years, and I think it's correct. But it's kind of something that you expect to see in nebula, in a protonebula. And that's the way we think the core of gas giants like Jupiter and Saturn formed, in fact, in our own solar system from these gravitational instabilities.
So, but when it comes to the planetary formation, so inside the nebula, what you're getting are the stars, but there's always dust that's left that's now orbiting those stars, and that dust and gas is what collapses into your protoplanets, right?
Yeah.
Okay.
And here maybe we don't know the size of this very Robin nebula. I don't know if it's a nebula that will form a large number of stars, or that's a nebula that basically has in the center a star and gas and dust around it.
Right. Well, we know there's one planet in there, so obviously some stuff has formed. So it seems likely to me that we have at least one star has formed in here. Yeah. Whether or not it's big enough to be a stellar nursery like the Orion Nebula is a different story. But obviously there is formation going on, because we do end up with one planet, and that planet is made up of dilithium. Star Trek science.
Yes, and I think I'm gonna skip the dilithium because it's not real science, and I've been trying to understand this, and frankly, I failed. So I'm sure someone will write a lot of comments here explaining to me the theory behind dilithium, but since it's not a real scientific element, I did not spend much of my time thinking about it.
The only thing I really compared it to was, I find it highly unlikely that a planet is made up of mostly a singular mineral. It's generally not how this works. But we have theorized that there are exoplanets that we found that are made of things like diamond.
Yeah.
So, it's not outside the realm of possibility. I just think it's outside the realm of probability.
And I also, in fact, this is something I wrote in my notes. I'm just looking at this. We also have seen asteroids made of one type of element. We think that Psyche, for instance, is mostly.
Oh, right. Psyche is like just iron, right?
Yeah. And we get picture of Psyche in the next 5 years, I think.
Yes, we're waiting for the mission to Psyche to launch.
Yes.
Which I think is this year.
No, this year is Lucy.
Oh, this year is Lucy. Yeah. So I think it's next year then. Next year is mission is Psyche. Okay.
And then you have to go there. It takes 2 or 3 years because we did not invent yet fast propulsion
warp travel. Yeah, faster than light travel. Yeah.
Yeah, we have to wait 3 years to go there, unfortunately. But we will get first picture of an asteroid which is made of iron and nickel, maybe, and that will be very interesting. Probably it's going to be very exotic if that's the case.
And one of the theories of Psyche's origin is that it may be the core, the nickel iron core of a planetoid. That it's not just look random chunk of rock. It's actually the center of something that tried to form and then got broken up possibly by Jupiter's formation, and the gravitational tugs didn't allow it to finish, or whatever. That's why we're sending a mission.
And that's yeah. So maybe this planet made of dilithium is also maybe also the core of some of a planet, a mist planet, a protoplanet that did not form properly.
Right, and especially, I mean, if we're looking at the chaos of this nebula, that could be a problem, right? That could cause a problem in planetary formation. So that might make sense. We'll just go with that. Okay, moving on from the dilithium issue and the Star Trek science side of things. So we've talked about the radiation poisoning and how this ionizing radiation can cause damage to the humans. So they're suffering from radiation poisoning. Grudge has had to go get healed up from being in there. Book has had to be healed from being in. We've left people on the surface of this planet experiencing it. We now understand why it's causing damage, but they talk about using DNA recombination to sort of fix this. So,
Yeah.
how, I know this is not our area in any respect because this goes heavy into the biology side of things. But what did I know you looked up some of it. So, what did you find out about DNA recombination, and is that possible?
So it does not exist yet.
Okay.
Just
Okay, so moving on. No, tell me some more.
I'm sorry, but we have not yet found a way to fix people DNAs at the molecular level, and that's what they're doing. So radiation, as I mentioned, are basically imagine you being bombarded by extremely energetic particles, for instance. So what happened on the first level, your organs will start failing. So that's what we see. We see them having this kind of bleeding, which are in fact visible part of what's going on inside the organism.
Right. You start to see the lesions on the
Yeah.
skin.
And you also
Right.
start seeing the lesion on the skin, which is the burning. In fact, it's kind of a burn and destruction of the superficie of the skin. But then you can fix that. I mean, if you look, people have survived this in after Chernobyl and other catastrophic nuclear disasters. But in fact, after a few weeks or months, or sometimes even years, unfortunately, these people get sick with a cancer.
Right.
Because
Because
what happened?
you've genetically mutated some cells and they learn the wrong processes for re multiplication. As
Yeah,
my husband said today, in biology, multiplication and division are the same thing. So they've learned the wrong processes for cell division and cell recreation, and so now it's become cancerous cells because they've of the radiation damage.
so that's what they basically say when they say we are going to do a DNA recombination. We are going to fix this. So to avoid this kind of long-term consequences of the radiation, and to do that, I don't know which technology they use. They use Star Trek technology, which is completely
Black
unknown to
box.
me.
Throw it in the black box. It comes out
Yeah.
fine. Okay.
This technology basically reconnect. You know, the DNA is a spiral
It's a
molecule,
double helix, right?
the double helix. So you basically reconnect this to the right combination, which is kind of magical when you think about it. But
Right. So I mean, they have everybody's DNA on file, so they
yeah,
can,
so they can
they can go
probably
back in and say hunt down pieces of DNA that are incorrect, and put your C's and G's and A's and T's back where they belong.
exactly. So apparently it worked well. I mean, you see, book is fine after a few minutes in the
And
hospital,
Grudge is fine.
and Grudge is fine too. So that's okay.
All right. So speaking of DNA, one of the things that we see in Star Trek a lot that keeps coming up, and I know this has bothered people over the decades, is the fact that there are so many humanoid style different aliens, right? So you have these bipedal characters with, two arms, two legs, two eyes, head, torso, that kind of thing. And it's all kind of the same construction. The details might be a little different. Klingons have forehead ridges, Andorians have antenna, but it's all sort of variations on a theme. So in our own galaxy, which is what this is, what does that mean for us? What is that something that as the SETI Institute we look for? Is this what we think might happen? Why? What do we I mean, I know what I know what the Star Trek explanation is, and it's one of those, oh, there's this group called the Protectors, and there's, they've seeded the universe, the galaxy, and whatever. But in reality,
considering the diversity of planets that we already have discovered,
right,
considering the amount of weird planets we have seen so far, it's very likely we're going to find as well very weird life, very bizarre life, things that we did not expect to see.
Right, like crabs have evolved 4 different times here on Earth.
Yeah.
Like, so everything is crabs, really.
It could be basically that the intelligent species that we will see will be very different to us. It could be different to us because of the biology, but the biology is not, the evolution is also linked to the environment. And I'm not a biologist, so I'm totally make this up. I'm sure I'm going to be corrected again. But imagine, like, if you are living on a planet which is bigger than Earth, has a bigger gravity, then you obviously will have a different structure or different size as well.
Right, because you can't necessarily, if you have a larger gravity, you're probably not going to grow as tall, but you might be more muscular.
Yeah. Could be smaller and shorter, or you could be living on a planet smaller or with a lot of gas around it, and you will be very elongated. And those are maybe intelligent species as well. And look at the diversity of our own planet, just our planet. Sometimes you see species on documentary animal show, you say, this is not from Earth, but yes, this is from Earth.
Especially, you look at like ocean life, like the further down you go, the weirder it gets. And of course, we do our own studies in extremophiles at the SETI Institute, and we've found life that can exist on sulfur. We found life that lives on snow. Like there's actually an algae that grows on snow. I've seen it. It's amazing. But these are places that we said, oh, there can't be life, and every time we say, oh, there can't be life, we're wrong.
Life there is very different.
Yeah, life is very different, but we do find it. Right.
So my point is that if the universe is so big and there is so many potentially habitable worlds, but they are very different, it's very likely that an intelligent species is not like us.
Do you think we're the first?
The first intelligent species? I don't know. I don't think. To go back to the story of Star Trek, they basically, you didn't say, but they basically claim that the reason for which all the species are identical is because there was some ancient humanoids who basically came early in our galaxy.
Right.
And for some reason disappear, but before disappearing, spread into our galaxy their matrix, their DNA. I don't know exactly what. What did they do? I didn't read much.
So there was this super race called the Preservers, and they seeded all these cultures, all these different primitive cultures on different worlds so that they could grow and thrive. And all of these cultures, all of these different species are basically genetically related but distant. So they kind of implied that they sort of colonized all these different worlds. And so a lot of it is maybe evolution from, those ancient civilizations, and everything evolves differently. So, you don't always get the same results. But basically, and this is from, I think this is from both the Next Generation and the original series, that what it comes down to is that some ancient life form has seeded our galaxy with, or at least our galaxy, if not the universe, with all of these ancient life forms on worlds where they felt they could thrive. And that's sort of led to this diversification of the same type of form. So it's all this bipedal humanoid type of life going on.
So one of my main points of this story is that it's totally possible, physically speaking. So let's go back to the numbers. Right. The universe is 13.8 billion years old.
Right.
The galaxy, the Milky Way, is 13.6 billion years old.
Right.
So imagine that as soon as the galaxy formed, it was full of these stars, which are very short-lived, OAB, very massive stars, right? And they exploded quickly after a few million years, 100 million years, contaminating the entire area of heavier element.
Right.
Then in this cocoon, other cocoons contaminated, additional new system formed, new stars and new planetary system formed.
Right.
And they form using this heavier material. So suddenly we could have a much more diverse world, planets which are not only Jupiter or Saturn planets, but terrestrial planets. The first generation of planets was probably Jupiter, Saturn planets. So later on that we could get the second generation of planetary system could have basically these terrestrial planets.
Right. So we get carbon and oxygen and iron and all of that kind of thing.
So imagine that now this planetary system evolve as life. 4 billion years later, intelligence life. 5 billion years later, life which is basically spacefaring and capable of traveling through the galaxy. And they realize that they are the first. Those are the ancient, you call them.
Right.
So
the preservers or the ancients, right? Okay.
Because they did not, because they're the first generation of a planetary system that could have potential terrestrial life. And what they did in the story that you describe is to basically visit worlds and find planet that could be habitable. I have a problem with that because it implies that there was an overlap in the evolution and the formation of our star, meaning that they survived long enough to reach the moment for which our star formed and our planet formed, and then they realized, so that was 4.5 billion years ago, and they realized that Earth could be habitable. So that means they live as a intelligent civilization for, let me just make a calculation.
Almost 10.
Almost, yeah.
10 billion years?
9 billion years.
Yeah, I'm on the scale of that.
They must be extremely, I don't know, maybe they're still here. They're so advanced that we don't see them. But if that's the case, why did they choose to implement life, which is still kind of the very primitive life that they were 8 billion years ago?
Right. Oh, that's a really good point.
If I was an advanced civilization, I will not spread life of myself when I was an Australopithec. I will spread life of myself now, right?
Right. Absolutely. There's been a lot of evolution over those, few million years.
Yeah. So imagine for 8 billion years, it's a completely different species. It's completely probably technology is different. There is stuff that we need to discuss more here, but my point is that it's possible that in our galaxy we had 8 billion years ago an intelligent species already, and maybe this intelligent species disappeared quickly after 100 million years, and we came much later on. So maybe one day, when we will be able to explore the galaxy, we will find relic of this intelligent species. And I think that's the most beautiful thing, that we're going to travel, we maybe discover a dead civilization.
And that is one of the things that I think we've talked about recently at the SETI Institute, even, is looking for those artifacts of civilizations, and not just for the signs of existing civilizations, but how to look for civilizations that no longer exist.
So you can imagine if they built this Dyson sphere or gigantic space station around the sun, we at the moment can detect that. Using the Kepler telescope, it was possible. So now using the TESS telescope, it will be possible as well, or even ground-based telescopes. Right. Maybe one day we will detect a transit, a small attenuation of light due to, we think, the passage of a planet between Earth and a host star, which will be weird. When I say weird, it will have a weird shape, right, or it will be variable in a very weird way, and that will be an indication of of the existence of a civilization that maybe does not exist anymore.
Wow, that's an amazing thought to have. I think that's kind of where we should close it off, don't you?
Yeah, that's
I
it.
like this. I like this hopefulness. I like this hopefulness that we're going to find something, that we have the technology and we can do this. Um, I don't know. I admit I haven't watched the episode after Sukal, so I need to do that. But my final thoughts on the episode were, I'm not sure I like where this went, and I'm kind of, you know me, I'm a huge Star Trek stan, so I tend to be very positive about it. But I really don't like the idea that Sukal is the reason for the burn,
For the burn.
that his DNA changes from being inside this nebula for so long, that that's what caused it. That, being left there and being changed by the nebula and his emotional state has what basically blew up all of the dilithium that was active at the time. And I'm not sure I like this storyline, because to find that it's this one person that's responsible, who is not in any state to understand what they did. And even if they were in any state to understand what they did, would you want them to? Millions of people lost their lives, and the galaxy was fundamentally changed from that moment on. And I would not want to be responsible for telling anybody that they are that one person. We saw how the Vulcans handled it when they thought it was their fault, and that was a civilization, and this is one single person. So I'm hoping the story goes slightly differently. I'm not sure. I'm a fan right now, and I'm a little brokenhearted to say that. How about you, Franck? What do you think? Where do you think this is going?
I've seen the the episode, so
You've
I
seen
kind
the
of
next
know
episode.
a bit. Yeah, I think the story is interesting about like this idea of this simulation into which this kid is stuck, and the hearing of that he had to learn about this civilization in a spaceship which is basically destroying the being destroyed slowly.
Hmm.
It's sad. It's very sad
It
that he
is
has
very
no
sad,
idea about what's going on outside.
and I don't think you can take him out of there. Like, I mean, again, don't mind me. I haven't watched the next episode, so don't spoil it for me. But I just, I don't know. I know we only have the next two episodes to cover, so we'll definitely, I will be back with you in a short time, I'm sure, to
To talk
do the
about.
next
Yeah.
episode. I gotta watch it, and then we're gonna record. But um, yeah, you guys. Ooh, I I want my hope back. I want my Star Trek hope back.
You will like the next episode.
Okay, all right. All right, everybody. I think that's it. We'll be back with the next episode in a couple days when we get find some time in our schedule. Don't forget to subscribe and ring that bell for notifications. Feel free to leave a comment, or 5 or 10, or tell us how much you love or hate the show. We value the comments. Be nice, and thanks for watching, everybody. We're glad that you spent like this half an hour with us. So thank you so much, and we'll see you next time.
Like.
Bye.